This is the key to topic 28, worksheet 1. And in topic 28, that's where you were discussing the idea of inverse functions and one-to-one functions. So let's look at number 1. And let's see, in problems 1 through 5, it says determine whether each of the following functions are one-to-one. All right, so remember a one-to-one function, definition of a one-to-one function. So when we talked about a one-to-one function, and remember the definition of a one-to-one function, first of all, it's a special function, and it's a function. So a function is one-to-one if this occurs. So if for each y coordinate, there is exactly one x coordinate attached to it. Okay, so for each y coordinate, there's exactly one x coordinate. All right, so number 1, we have this set of ordered pairs. So we have this relation. We have 2, -3. We have 4, 5. We have 3, 7, and 6, 3. All right. Now, notice you're told all these are functions, and this relation is a function, but the question is this function one-to-one? And remember, when you have a set of ordered pairs, the best way to determine if it's one-to-one is use that mapping just like you did in a previous lesson a while back when you were asked to determine if a relation is a function. But instead of saying xy, like you did before, you remember we now use yx because it says for each y, there's exactly one x. So for each y, you want there to be exactly one x. Okay? So start with each one. When y is -3, my x value is 2. So far we're okay. When y is 5, my x value is 4. All right, so far we're okay. For each y, there's exactly just one x coordinate. When y is 7, I get the x value 3. And when y is 3, I get the x value 6. So notice that for each y coordinate, there's exactly one x coordinate. So this is one-to-one. So this function is one-to-one. Okay? So the answer for number 1 will be yes. All right, let's look at number 2. Number 2, we have this relation. So this function has these ordered pairs: 3, -4, -2, 5, -8, 7, and 6, 5. Okay? And we're going to use that same idea, that mapping, just like you did in a previous lesson when you talked about functions. So instead of saying x to y, you're going to say y to x, because that's what the definition says. For each y, there's exactly one x. So you're going to say y and then x. So when y is -4, my x value is 3. Okay, we're good so far. When y is 5, my x value is -2, right? So we're good so far. When y is 7, my x value is -8. We're good so far. So notice that for each y coordinate, there's exactly one x coordinate. But here's the problem. Look at that one. Y is 5. Now, don't listen again. You already have it listed. Only listen once. When y is 5, you have your x value of 6. So notice that when y is 5, there are two x coordinates. So notice that when y is 5 and y equals 5, there are two x coordinates. And so the definition of a one-to-one function says that for each y coordinate, there has to be just one x. That's not the case here. So this is not a one-to-one function. All right, so that's not a one-to-one function. So the answer number 2 is no. Okay? Now, number 3, now you've had enough experience from a previous course and also in this course to know that this function is a linear function. So in number 3, you know it's a linear function, right? And in particular, you know that the slope is positive, correct? Slope is positive. So you know that the graph's going to look like this. And so notice that it passes the horizontal line test. So this passes the horizontal line test. So remember, when a graph of a function is given, you can use the horizontal line test. Remember in previous lessons when you talked about functions, you use the vertical line test. Here you use the horizontal line test. It passes the horizontal line test to determine if a function is one-to-one. So notice that this linear function has a positive slope, and it passes so it looks like this, and so it passes the horizontal line test. Even if it had a negative slope, it would still pass the horizontal line test. All right, so this is one-to-one. So g of x, which equals 4x plus 7, is a one-to-one function. Okay, so in number 3, the answer is yes. In number 4, here you can see that okay, so that's number 4. All right, so here's the graph, and notice that it passes the horizontal line test. So passes the horizontal line test. So the answer is yes. Number 5 is a quadratic function, and so notice that in multiple places it fails the horizontal line test. So notice that for this y value right here, for this y value, and even this y value and this y value, there are 2 x coordinates. So notice it fails the horizontal line test. And so therefore it is not a one-to-one function. Okay, number 6. Okay, so they want you to determine the inverse of this function. All right, so notice that this function is one-to-one. Now all these functions are going to be one-to-one functions. And so if a function is one-to-one, it has an inverse. And now they didn't ask you to show it that it's one-to-one, but notice that this is a linear function, right? So that's a linear function. It has a positive slope, so it passes the horizontal line test, and so it's a one-to-one function. So it has an inverse, and you got to find the inverse. Now, in number 6, you could have done this without showing any work, and notice I didn't say show work here. So remember, the inverse does what the function does. So notice this function takes x, multiplies it by 7, and then adds 2. The inverse does the opposite. So the inverse will subtract 2 and then divide by 7. All right. But if you wanted to do this algebraically, here's what you would have done. So here's number 6. And so remember the steps for finding the inverse of a function. So here's number 6. So number 6, we have f of x is equal to 7x plus 2. So remember, step 1 was to replace f of x with y. So step 1, remember, is this. Replace f of x with y. And so therefore we get y equals 7x plus 2. Step 2, remember, is to interchange the variables. So interchange the variables. Okay, so interchange the variables. And so therefore the x becomes y, the y becomes x. So we get x equal 7y plus 2. Step 3 is to solve for y from this part here. And so now, remember when we talked about this, this is a linear function. Linear functions are always easy to figure out the inverse of. So this function takes x, multiplies by 7, and subtracts 2. The inverse does the opposite. So the inverse will subtract 2. Notice it does that, right? So you solve for y. So I'm going to go ahead and rewrite this over. So you're going to subtract 2. That's what we said. And then you're going to divide by 7. So when I subtract 2, though, I get x minus 2 equals 7y. And then to get y by itself, you can divide by 7. And so you get y equal x minus 2 divided by 7. And then step 4 is to replace y with f inverse. So that's the inverse. So this y is the inverse. This y is f of x. This y is the inverse. All right, so don't confuse those two. So this is f inverse now. All right, and so therefore we get, so step 4, you'll say f inverse of x is equal to x minus 2 divided by 7. So x minus 2, that's a 2 right here. X minus 2 divided by 7. So x minus 2 divided by 7. Number 7. Okay, so first of all, in number 7, notice that this is a quadratic function. And so you may say, well, a quadratic function is not one-to-one. That's true, but we're restricting the domain. So that's important. So notice that if you were to graph this, and you didn't have to, but if you were to graph this, you take your parent function x squared, move it down 5. So 1, 2, 3, 4, 5. And then you're only looking at the part of the graph where x is greater than or equal to 0. So that's on this side. So notice you're looking at this. So notice it passes the horizontal line test. All right. And so to determine algebraically what the inverse is, so now I see this graph, which has this restriction, is this. So it passes the horizontal line test. So therefore it's 1-to-1. So since it's 1-to-1, it has an inverse. All right. So let's find the inverse. So first of all, f of x is this. It's x squared minus 5. All right. And so remember, though, that x is greater or equal to 0. So that's our restricted domain. Okay, so step 1, remember, replace f of x with y. So we get y equal x squared minus 5. Step 2, interchange the coordinates. So switch the coordinates. So step 2, you're going to say x equal y squared minus 5. Now at that point, since I switched the coordinates, we also have this. We have y is greater than or equal to 0. So x becomes y. All right, so that's your range right here. This is your domain. This is your range, okay, at this point. All right, now step 3 is to solve for y. So step 3. So I'm going to add 5 to both sides. So I'm going to rewrite this over. Add 5 to both sides. So I get x plus 5 is equal to y squared. And then to get y by itself, since I'm square, I'm going to take the square root. Now here's where some of you forgot something. So some of you are going to say, well, I remember when solving an equation and I took the square root of both sides, I had to do plus and minus. That is true. But remember, you restricted the domain. So notice that I'm only looking at the y values now that are positive. So you're not going to do plus and minus. You don't want the negative. You don't want y to be negative. You want y to be positive or 0. So don't do plus and minus. You're just looking at the positive square root. So y equals the square root of x plus 5. And there's your inverse. Okay, so that's the inverse. So step 4, you're going to say the inverse will equal the square root of x plus 5. All right. So some of you are going to do plus or minus 5 and forget about the fact that if you do plus or minus 5, then the inverse of this is no longer when you do plus or minus 5 and you graph this, then that's not the inverse of that anymore. All right. So just be careful. You restrict the domain. So when you interchange the variables, this x became y, and remember y is the set of your range. So set of y is your range, and so when you take the square root of both sides, you want y to be positive. So you take the positive square root only. Okay. So that's number 7. So number 7, the inverse is the square root of x plus 5. Okay, number 8 is a cubic function. So you know that all cubic functions are let me rephrase that. this cubic function, all you're doing is adding a constant to it. So all you're doing is taking x cubed and shifting it up 9 units. So that is still 1 to 1. So remember, x cubed is 1 to 1, but when you shift it up 9 units, it's still 1 to 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks something like this. All right, so notice it passes the horizontal line test, so it's 1 to 1. Since it's 1 to 1, it has an inverse. Okay, now let's find the inverse. So to find the inverse, you do all the steps, same steps, nothing different. So number 8. So number 8, g of x is this. Okay, step 1, you replace g of x with y. So y equals x cubed plus 9. Step 2, interchange the coordinates. So interchange the variables, I should say. So y becomes x and x becomes y. Okay, and then step 3 is to solve for y. So I'm going to subtract 9 from both sides, and we're going to rewrite this over though. So I'm going to subtract 9, and so I get x minus 9 equal y cubed. That's cubed. And then remember, right now I'm cubing y, so the opposite is to cube root. So when I do that, I get this, and there's your answer. So y equals the cube root of x minus 9, and there's your inverse. So g inverse of x. Okay, so that's your inverse. So remember, step 4 is where you replace. Step 4, remember, is where you replace y with g inverse. So g inverse of x is the cube root of x minus 9. All right, and so that is going to be this one. So so that's the cube root of x minus 9, right? And that's it. Okay, so that is, and that's all you do there. So that is the key to let me make sure I'm putting the right one. I'm sorry. So I'm going to use this one. So this is the key to worksheet 1 of topic 28.